So let's look at another scatter plot. This is data on bird population. The table below shows the number of woodpecker clusters in a part of the forest. So we wouldn't expect this to be a perfect line because they're birds. Write an equation that models the number of active clusters as a function of the number of years since 1990. Guys, this is very important. The number of years since 1990. So that means that X is your year, but you don't use 1992 for X. What is 1992? How many years since 1990? It's 2 years since 1990. So instead of 1992 in your graph and in your data, you're going to use 2. How many years since 1990 is 1993? 3, 4, 5, 6, 7, 8, 9, 10. Be very careful when you're given a year on a problem. They will almost always tell you to use the number of years since this instead of using the actual year. You're going to get the equation totally wrong if you use the actual year. So let's make a scatter plot. Let's plot our data. So when X is 2, Y is 22, the next one, now you're going to have to kind of guess on some of these, get close because they're not going to be exact. If you need to pause the video while you plot your data, then go ahead. All right, that was number 1, make a scatter plot. Number 2, does it show a correlation? Yes. Doesn't it show a positive correlation? It's going in a positive direction. So that means as X increases, Y increases. As the years increase, the clusters, the active clusters increase. So the woodpeckers are reproducing. We've got more woodpeckers and more active clusters. So let's draw a line that fits the points. Remember that our line needs to go as close as possible down the middle of the data, where we have about, Miss Jones didn't do a great job here, but we have about as many points under on one side of the line as we do on the other. Now write an equation for that line. So here's a couple of things we can do. I want to show you both ways. So what we can do is we can pick 2 good points. That means points that are almost on the line, and don't put 2 too close together or your data won't be as accurate. So how about let's pick this one. What point is that? 634. And let's pick this one. How about 1051? So I'm using this one and this one. So let's do our point slope form. Yay, Miss Jones, we love point slope form. The first thing we have to do is find the slope. Let's go 51 minus 34 over 10 minus 6. Now, I'm probably going to keep this as a fraction just because I know it might be a messy decimal. So it looks like that would be 17 over 4. Let's just go ahead and leave that as 17 over 4. So let's pick one of our points. I don't know, I guess I'll just pick that one. Y minus 34, remember y minus y1, equals the slope times x minus, what's x1? 6. All right, I used point slope form with this slope and this point. Distribute y minus 34 equals 17 fourths x minus, let me see if I can do this in my head real fast. 51 over 2. I hope I did that right. Now, if you want that as a decimal, the y-intercept's usually easier to have as a decimal. So if you want it, I think I just showed you all my password. If you want it, let's use calculate 84. If you wanted to have that as a fraction, as a decimal, 17 over 4, use your calculator, times negative 6. Did I forget to do, nope, I did it right. So 25.5. So instead of the fraction, since that worked out to be a nice decimal. Now let's add the 34. Please don't act like you've never seen this before. So now I have 34 minus 25.5. I think that's a negative 8.5, but just to be sure and check my math in my head, let's go plus 34. Yes, plus 8.5. Now, so there's my line of best fit. Because now that was a lot of work, wasn't it? But we do hard things. We know how to do work. But can't we do what we just learned and go to Stat, Edit. Now if you will arrow up to the L1, highlight it and hit clear. It didn't work. Let's try this again. Maybe we can't do that then. Let's go down. I guess it doesn't work on this app. We're going to have to delete all of our data that we used last time. Or, like I said, you can always go second plus 712. Here's our X column. So instead of putting 1992 in the X column, just put 2. Pause the video if you need to go ahead and put this in your table. So let's put all the X's in L1 and the Y's in L2. Now, make sure you have an even number, that L1 and L2 come out evenly, or you've left something out. Go to Stat, go to Calc, go to 4, hit Enter. Here's your equation. Let's see how close we got. The y-intercept's 12.5, so our y-intercept's a little bit off, and then 3.7. So when I did the regression, I'm going to get more accurate because I used every point instead of just the 2 points I used when I did it by hand. I may not have used the 2 best points. I may not have drawn my line great. So maybe that's the difference. So let's go see what 17 over 4 is as a decimal. So 17 divided by 4 is 4.25. I got pretty close on my slope, so I got fairly close. So you can either pick 2 points and do it by hand, but if you have the calculator, when you have a linear regression, use Stat. And I'm going to put directions on Canvas in case you don't remember. And if you don't have Calculate 84 and I do not have the ability to get it, you are going to email me and we're going to see what we can do. Bye, guys.